Hello students, this video is to explain the difference between slugging percentage and batting average for quantitative reasoning. We're going to be talking about baseball, so if you like baseball, that's great. If you don't like baseball, that's okay. It's two very easy calculations, two pretty straightforward formulas. All right, let's take a look at a sample baseball player. This is Derek Jeter. He won his first MVP during 1997 to 1998. Here are his hitting stats. He had 654 at-bats, 142 singles, 31 doubles, 7 triples, and 10 home runs. Now, just to be clear, this at-bats, you can think of this as tries. And if you want to write that down in your notes, you can. At-bats is tries or attempts. This is how many times that Derek Jeter had the opportunity to get a hit. And then singles, this is where he hit the ball, was able to get to first base. He hit the ball and got to second base for a double. Hitting the ball and getting to third base is getting a triple, and then hitting the ball and being able to circle all 4 bases is a home run. But the long and short of it is all of these singles, doubles, triples, and home runs all count as hits. So what we can do is if we want to know the total number of hits, like for batting average, if we want to know the total number of hits, we have to combine singles, doubles, triples, and home runs. So, like I said, adding them together, we're going to get 190. This is the total number of hits. So, of course, in quantitative reasoning, when we try to calculate a value, a number, we always want to use its units. So this is 190 hits. So now the question is asking, what is Derek Jeter's batting average during this season? Well, you see that batting average is equal to total number of hits divided by the total number of at-bats. Remember, that's like attempts or tries. So it's a pretty simple calculation. We do the number of total hits, which is 190, divided by the total number of at-bats, which is 654. All right, and we put it into our calculator and we get 0.29051, et cetera, et cetera, et cetera. So this would be annoying to report, especially if I was, writing an article on sports. I wouldn't say, Derek Jeter's batting average was 0.290519. So sports writers and baseball statisticians have agreed that we usually express a batting average and a slugging percentage as 3 decimal places to the nearest thousandths place. So in order to figure that out, we look at this, which is the thousandths place, and then the next number, if it is 5 or above, we round it up, or if it is below 5, we round down. Next number is 5, so we're going to round this up to 0.291. And in general, the way that we say it is his batting average was 291. It's weird to say it as 291 when it's a decimal, but that's just how it's said when you talk about baseball. Okay, great. So this is Derek Jeter's batting average. Let's contrast that with his slugging percentage. We have the data on singles, doubles, triples, and home runs, and we know that slugging percentage is more of a weighted average. It's weighted because singles only get 1 because you get 1 base. Doubles is valued as 2 because you get around to second base. Triples is valued as 3 because you get to the third base, and for home runs, you go around all 4 bases, so it's valued much more highly, 4 times as highly as just getting a single. So we call this a weighted average. If we were to determine his slugging percentage during the season, we'd have to fill in these values with the numbers that we know. We know his singles, doubles, triples, and home runs. That goes in the numerator. And then the at-bats, the tries, goes in the denominator. Okay, so we have the slugging percentage formula here. 1 times singles, 2 times doubles, 3 times triples, and 4 times home runs divided by at-bats. And you can see I just took the numbers from the problem and substituted them in. This is singles, number of doubles, number of triples, number of home runs, and at-bats or tries or attempts is 654. So now I'm going to figure out the numerator and then divide it by the denominator. And we get to 265 over 654. That gives us 0.405198777, etc., etc. I should say it keeps going. However, just like with batting average, slugging percentage is rounded to the nearest thousandth. We call it the rule of 3 sometimes. So the slugging percentage for this player is 405. And of course, we didn't round this one because here's the thousandth place, the 5. The next number here is a 1. It's less than 5, so I keep the 5 the same. If this number had been, 7 or an 8, I would have called this 0.406. Just explaining rounding, I guess, just in case you forgot. All right, next, I want to talk about baseball cards briefly before I let you go. On a baseball card, in general, what you will see is the number of at-bats, the number of hits, doubles, which is 2B, that stands for doubles, 3B, that's 3 bases or a triple, and then HR, which of course stands for home runs. What's missing from here? Like if I was trying to calculate Lenny Dykstra's slugging percentage, what's missing? And what can we do to figure it out? Take a minute, pause the video, try to figure it out, and then come back to see if you got it right. Okay, as you can probably tell, I'm going to go back to the title screen for a second. The slugging percentage asks for singles, doubles, triples, and home runs. However, on the baseball card, it gives you the doubles, triples, and home runs, but it doesn't give you the singles. It gives you hits. But you should realize, or you should remember, that hits is the total number of singles, doubles, triples, and home runs. So if they give you the total number of hits, which they do, and they give you doubles, triples, and home runs, which they do, you can subtract the total number of doubles, triples, and home runs from the hits in order to get the singles. Hopefully that makes sense. Okay, so now that we have this information, let's determine the slugging average of Lenny Dykstra during the 1986 season. In order to figure out his slugging average or his slugging percentage, we have to take all of the non-single hits, the doubles, triples, and home runs, and subtract them from his hits. So here's his 1986 stat line. He had a 295 batting average. He had 147 games, which we don't really care about. But we do care about the at-bats. That's the tries. That's going to be the denominator. We have the number of hits, which we need to subtract the doubles, triples, and home runs from. Here's doubles, here's triples, here's home runs. We don't really care about RBIs and stolen bases because that's for a different calculation. But now we have most of the information that we need. So pretty straightforward way of finding that number for singles. So now we have his singles. The doubles are here. The triples are here. The home runs are here. The at-bats are here. We have everything we need in order to cook up this slugging percentage. Here's how I'm going to set it up. I have 1 times singles, which I found was 85. 2 times doubles, which I know is 27, 3 times triples, which is 7, 4 times home runs, which is 8, it says here, and then 431 is the at-bats. It's not the games or anything else. It says at-bats, AB. All right, now I'm going to put it in the calculator and round it to 3 decimal places. Here's that numerator. It should be 192. 1 times singles, 2 times doubles, 3 times triples, 4 times home runs. Now I'm going to divide that by 431. And I'm going to get a big crazy decimal, but again, I rounded to 3 decimal places, so 0.445. Next number is 4, so I keep that 5 where it is. So 0.445 seems to be my answer. This procedure is important because your task for this unit is to get a baseball card, which I believe that you've already received in class, and calculate the slugging percentage for certain seasons of the person's career. All right, this was a video on slugging percentage versus batting average. I talked about the differences between the two calculations and how they're used when you're given a baseball card. All right, folks, good luck studying.